Why space is dark? The color black usually signals the absence of light. But inside the solar system, space is filled with light. Light usually travels in a straight line, ahead in a line, unless it reflects off something or is bent by leans. Think about how can you see the spot of light or a laser point, but not the beam.
The light that makes up the beam just goes ahead to where the pointer is pointing and not your eyes. Why is space dark? This question was famously asked by the German astronomer Heinrich Wilhelm Olbers, who described it in 1823. We call this Olbers Paradox after him. The apparent paradox that if stars are distributed evenly throughout an infinite universe, the sky should be as bright by night as day. Since more distant stars would be fainter but more numerous, this is not the case because the universe is of finite age and the light from more distant stars is dimmed because they are receding from the observer as the universe expands.
Because of the most universe is empty and the outer space looks blank. The paradox is that a static infinitely old universe with an infinite numbers of stars distributed with an infinitely large space would be bright rather than dark.
This is the view of three concentric shells.
To show this, we divide this universe into a series of concentric shells, 1 light year thick. A certain number of stars will be in the shell, 1 billion to 1 billion and 1 light years away.
If the universe is homogeneous at a large scale, then there would be 4 times as many stars in this second shell, which is between 2.0 to 2.0 plus 1 billion light years away.
However, the second shell is twice as far away, so each star in it would appear 1/4 as the brightness as the stars in the first shell.
Thus, the total light received from the second shell is the same as the total light received from the first shell.
This infinite universe includes stars and dust. When we do, we find that yes, in fact, universe is full of stars and galaxies. From millions, billions or even tens of billions of light years away, starlight travels across the universe and reaches our best observing equipment.
It might take a long time to catch enough photons from such great distance, but the color of the photons is directly related to its frequency. It can be understood by this formula. E is equal to hf, where E is equal to energy, h is the Planck's constant and f is the frequency.
And guys, don't forget to subscribe our channel.